Forget frequently asked questions, common sense, common knowledge, or Google. How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5% go above and beyond and become very good at what they do. But only 0.1% are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in fields such as sleep science, cancer, stem cells, ketogenic diets, and more. Get ready. Here come the geniuses. This is the Finding Genius Podcast with Richard Jacobs.
Hello, this is Richard Jacobs with the Future Tech and Finding Genius podcast. I've interviewed over 2,000 people the past 3 years, clinicians, researchers, scientists, etc. It's my goal to find the geniuses in the different fields and bring them to listeners. So I have a great guest today, Professor Richard J. Johnson. He's at University of Colorado, Denver. He's authored a number of books. There's The Fat Switch, there's The Sugar Fix, and we're going to be talking about obesity, sugar, metabolic health, those kind of issues. So, Rich, thanks for coming. How are you doing?
Thank you, Richard. I'm delighted to be on your show.
Yeah. Well, tell me, what got you into looking at metabolic health, and what's your research and your work about?
All right. Well, I've been doing research for many years. I'm a kidney specialist, and I started off by studying kidney disease and high blood pressure, which is thought to be a problem of the kidneys getting rid of salt. And in the process of studying these, I came into studying metabolic syndrome and the role of nutrition, and particularly of sugar. And our work focused early on fructose, which is a component of table sugar and high fructose corn syrup. And we kind of became experts on that field and helped try to figure out what it was special about fructose that could lead to obesity and diabetes.
Okay, so, I know a lot of people think of sugar as glucose, but I guess table sugar is what, a mixture of glucose and fructose or sucrose? Or Tell me a little bit about the basics of sugar, first of all.
Yeah, sure. So sugar, or table sugar, the white sugar that we put on food, is sucrose. And that is actually two sugars bound together. There's a glucose molecule and a fructose molecule, and they're bound together. And the fructose is the sweeter of the two. We love sugar because we like both the glucose and the fructose. They both activate the sweet taste receptors and give us a little pleasure response in our brain. The other big sweetener that's used out there is called high fructose corn syrup. From corn, and they treat the corn syrup to generate a mixture of fructose and glucose. So it's the same type of thing as table sugar. It's a mixture of fructose and glucose, but they're not bound together. And there tends to be a little bit more fructose than glucose in the syrup, and that makes it a little bit sweeter. And people tend to prefer that, and because it's liquid, it can be mixed into foods very easily. And so high fructose corn syrup gets into lots of foods. Like 70% of our processed foods have high fructose corn syrup in it. And so these are the two major sweeteners together. They make up, maybe 15, 20% of our diet comes from sugar, added these sugars.
So what, when do you see patients, or did you for a while and did you stop? Like, what's your clinical practice look like?
Oh, I'm a workaholic, Richard. So I have an active patient clinic. I have clinics and I see patients mainly with kidney trouble or with high blood pressure, but I do pretty much all general medicine as well. And then I have a very big research program. I've published hundreds of papers actually over the years, and been funded by the National Institute of Health and the Department of Defense and a number of places. So I keep myself busy.
Oh, yeah. Well, I've spoken to a lot of people about the effects of sugar, and not that I don't want to speak about that, but since you're a kidney specialist, it's much rarer that there's people out there that know about that. So how does sugar play into kidney disease and high blood pressure?
Well, it's a big story. So sugar is a risk factor. Sugar intake is not just a risk factor for obesity and diabetes, but it's a risk factor for kidney disease and a risk factor for high blood pressure. And actually, it's a risk factor for many, many types of diseases. And our group has done some work on the history of fructose and how it works and why it does what it does. And it's sort of interesting. It originally was a sugar. It's in fruit and honey. And originally, its actions were really to help animals survive. And so fructose was really a good guy for a long, long time. And so many, many, many animals rely on fructose as their way to protect themselves, like from hibernation, during winter when there's no food around, they'll eat sugar or fructose in particular in the fall to put fat on to help protect them. And they'll even become insulin resistant by eating fructose to protect them, because when you become insulin resistant, the glucose in the blood goes up, and that provides a fuel for the brain, because normally the muscles want the glucose and the brain wants the glucose and the liver wants the glucose. But if you become insulin resistant, the muscle can't take the glucose up so well, so it goes to the brain. So it sort of, insulin resistance is a protective response. And so it turned out that sugar and fructose in particular used to have be more of a survival factor for animals. And but when you eat tons of it, it goes from being a survival factor to actually driving a lot of diseases. So that's so obesity and diabetes are just two manifestations of high sugar intake, but you can get kidney disease, you can get fatty liver and cirrhosis. It probably has behavioral effects. It has a wide variety of actions that are not good, and it's ironic because it was meant to be a good pathway, and that's why we are so sensitive to sugar, is because we actually there was times in our past when we utilized fructose as a survival factor, but now it's kind of bad news for us.
So how much sugar in an average person's diet you think is safe, and how much are people having in your estimation?
Well, the diet varies, and if you're a teenager or young adult, it's not uncommon at times for some people to eat 1/4 of their diet as sugar. Especially soft drinks, they can have so much sugar. A soft drink can have the equivalent of 10 to 12 teaspoons of sugar in one drink, and you have no idea how much sugar is in some of these foods, and so it can make up maybe up to 1/4 of the diet in some people. That's a lot. So there was just to give you an idea. In 1700, the average person ate 4 pounds of sugar a year. And in 1800, it was 18 pounds. And in 1900, it was 90 pounds of sugar in a year. And now we're eating like 150 pounds of sugar a year. That's a lot of sugar.
Yeah.
So some people are eating 1/2 pound of sugar a day, but it's a lot.
For simple math, a pound is what, 454 grams?
Yeah, I think that's right.
So some people are eating 220 grams of sugar a day, you think?
Yeah, there's probably some people eating that much, yeah.
How much do you think the average adult is having a day? What's your estimate?
Oh, I'd have to pull the papers, but it's I would say probably 300 calories a day of sugar. So that'd be maybe 75 grams or so.
Okay. Well,
yeah, but there, if you go to Dairy Queen, you can eat a dessert that has 70 grams of sugar in it in one big swoop.
Well, what's some of the nuance of sugar? Is there anything about it that isn't so bad? If you're eating a lot of sugar, but it's all from fruit, is that so bad? Is there anything you can do to modulate?
Yeah.
If you just love sugar and you want it, anything you can do?
Yeah, absolutely. So the first thing is natural fruits. Okay, they have fructose in them. They're sweet. If you really have that craving, you want to eat something sweet. Natural fruits, many of them have small amounts of sugar relative to like a soft drink. So they may have like 4 to 8 grams of sugar. Like apple might have 8 grams. Strawberries may be, like 4 grams for a serving, 5 grams. And that turns out to be healthy. And what's good about it is it's not the sugar in it. The sugar is the sugar no matter what. The fructose is fructose. But in the natural fruits, there's a lot of good things. There's like fiber, vitamin C, a lot of things called flavonols and antioxidants. There's many, many different compounds. And a lot of those neutralize the fructose. In fact, we've done studies where we've looked at the different components in fruit, and a lot of them will neutralize, especially like vitamin C actually partially neutralizes the effects of fructose to cause fat storage. And so if you eat a few natural fruits a day, that turns out to be pretty healthy. Now, if you eat a lot of fruit, like especially if you put it in a blender and make a juice, and you get rid of some of the fiber and just drink the liquid, then you get a lot of sugar in one big swoop. You could get 20 grams, like an apple cider, for example, will have about as much sugar as a soft drink. And then in that case, you don't get the benefits. So the Pediatric Society has figured out that fruit juice isn't so healthy for children. And so you need to limit fruit juice in children, and it's associated with obesity. And it's the same for adults. Fruit juice and fruit drinks are associated with diabetes and obesity. And also dried fruit, because when you even though it tastes so good, those dried apricots and, how much we love those dried fruits, but they get rid of a lot of the good things and you're left with the sugar. So if you want something that's healthy, that has sugar, take a natural fruit, but don't drink any liquid sugar. Liquid sugar is a bad thing because the way the sugar works, the way fructose works to cause obesity is when you eat fructose, it drops the energy inside the cell. It's the only nutrient, Richard. It's the only nutrient that when you eat it, your energy level goes down before it goes up. And so normally when you eat a nutrient, you want the energy to go up so you can do all the things you want. If you eat glucose, your energy goes straight up. You make energy from the moment you eat it. But when you eat fructose, it's the only nutrient that actually drops the energy in the cell. It's like an alarm clock. It's like an alarm system. And when that alarm goes off, when the energy falls, the body says, we're in trouble. We got to eat. We got to put food on. We got to prepare for a disaster. We got to become insulin resistant to protect the brain. We have to raise our blood pressure to keep our blood pressure up. We have to activate our inflammation system so we can protect ourselves. And that's great when you're an animal in the wild and you get some of those fruits and honey and stuff like that. You do that. It's actually a survival mechanism that helps you. But if you eat tons of sugar, the inflammation turns into risk for heart disease and hardening of the vessels. The increase in blood pressure suddenly becomes hypertension. The insulin resistance suddenly becomes diabetes. The fat storage suddenly become obesity. And man, suddenly you're like in trouble. And, fructose has some other effects that animals use it to reduce their oxygen needs. There's a mole rat. I don't know if you ever heard of him, the naked mole rat. This little guy lives a long time actually, and he burrows in the mud, and he burrows deep. Actually, he burrows deep into these little burrows where there's no oxygen, and you put a little mouse in there, and the mouse will die because there's so little oxygen. But he does well, and the way he does it is he starts making fructose, and when he makes the fructose, it actually protects him from the low oxygen. It's a survival factor. But guess what? Cancer cells, when they are spreading around the body, they initially don't have any oxygen because when they get to a tissue, they don't have much blood vessels to them. They have to create it. So they're living in a low oxygen state. So guess what they found out in the last few years? Guess what is the favorite fuel for breast cancer, for colon cancer, for liver cancer, for pancreatic cancer? Guess what their favorite food is? Fructose. Yeah, because the fructose helps them because it decreases their need for oxygen, and they want, and in order to live in that setting, they're in a low oxygen state, so it's the perfect fuel. So it isn't that sugar doesn't cause cancer. Sugar feeds cancer. So it just
okay. So I guess cells undergo what's called oxidative phosphorylation, but they're using glucose as their normal pathway. But
the way you should view it is you're making energy most of the time through energy factories called mitochondria. And we have all this machinery producing energy in our body. And the professional place where it's done is the mitochondria. They're kind of like the factories pouring out energy, but they require oxygen to produce that energy. There's an old primitive system called glycolysis, which is where they make energy. You don't need oxygen. It doesn't make as much energy. Well, fructose tends to want to turn down the factories and turn up the glycolysis. And it does it for a purpose. It wants to decrease the metabolism. And if you're producing, everything turns down, it actually helps the animal survive. It's like surviving in hibernation. It's surviving. You have to kind of turn down the system so you don't burn off all the fuel. And one of the big, you just have to cut back on your big factories, and you switch to more primitive ways to make energy. And so this fructose is used by all these animals as a way to help them survive under extreme conditions. And actually, even in our history, we've at least twice humans almost went extinct, or our ancestors did, and we relied on this system to help us survive. But now we've trained ourselves. We're sensitive to sugar. We've gotten really sensitive to sugar, and we've learned how to make it, and we don't know how to regulate it, and so we just keep eating it, and we get hooked on it, and now all these things that were once good are killing us.
Does our body change glucose to sucrose to fructose, or does it produce fructose on its own under certain conditions?
Yeah, it does. So we had a paper in a Nature journal where we showed that the way high glycemic carbs work, the way that a high glycemic carb makes you fat and diabetic is because it's not the starch itself. But when you eat potatoes and chips and rice, they raise the glucose in the blood a little bit, and that stimulates in the liver the production of fructose. And if you block the fructose from being produced in the liver in an animal, then glucose doesn't cause obesity or diabetes. It causes a little bit of weight gain, but it mainly, it won't cause diabetes or fatty livers. The diabetes and fatty liver from sugar isn't from the glucose. It's from the fructose. The glucose gets turned into fructose.
But why would your body produce fructose? What's the function? Why does it do it?
Well, because there was a time in our past when we were struggling to survive. And I've actually studied this. So there are different periods, but we almost went extinct 15 million years ago. And I don't know if you want me to tell that story, but I'd be happy to. Yeah. Okay. Well, so one of the things that fructose makes is uric acid, and glucose does not make uric acid, but fructose does. And the way it does is when fructose drops the energy in the cell, the energy, which is called ATP, gets broken down to uric acid. And so you produce this uric acid, and this is why sugar can cause gout, because uric acid is, when it crystallizes in joints, causes gout. But uric acid also has biological properties. And so one of the things that uric acid can do is it and some of its products can actually stimulate fat production in the liver and in the body. And so it turned out that humans have much higher uric acid than most mammals, and it makes us more sensitive to the effects of sugar, because when your uric acid goes up, you respond to sugar with a much more prominent fat response. And so uric acid is a way to amplify the effects of sugar. So if I give an animal a slug of fructose and its uric acid is high because I've manipulated it, it will put on more fat for the same dose of fructose than if the uric acid's low.
Is it a vicious circle? So exposure to fructose seems to raise uric acid, what you're saying, and then once you're in a high uric acid state, that makes it more conducive to producing more fructose or storing it?
Yeah, making more fructose as well as responding to fructose. This is why people with gout often are overweight and diabetic, because the uric acid feeds into it. So interestingly, there was a time when our uric acid levels were low, and this was like millions of years ago. And there was this, in evolution, around 20 million years ago, the first ape appeared in Africa. And these were different from all the monkeys and stuff. These guys had big heads, big brains, and they were tailless. And back then, there were Africa, where these apes were. They were living mainly on fruit, and they were quite successful, many species. And then global cooling started to occur around 15 million years ago. And as the world cooled down, the water levels in the oceans fell, and Africa, which at that time was an island, suddenly had land bridges to Europe. And a lot of these apes and giraffes and elephants and rhinos and anteaters and all kinds of animals crossed the land bridge into Europe and Asia. And then they continued to live on fruit in Southern Europe. And it was still tropical, and they had fruit all year round. And then as it got cooler and cooler, the apes up in Europe started to die out. But there was this very interesting finding. There was a mutation that occurred right around then that affected uric acid, and it made all these apes have a higher uric acid. And that mutation occurred right around that time. And we figured out that the mutation actually increased the response of the apes to fruit, that they could make more fat from fruit. And it turned out that these apes were starving because of global cooling, because the fruit trees started to die out. And the apes in Europe started going extinct. But when the mutation occurred, what happened was it allowed them to survive on the very low levels of fruit that were available. And then some of them actually made it back to Africa and also to Asia, where they went on to develop into the great ape, but also into humans in a separate lineage. So we actually resurrected the extinct gene, and I worked with anthropologists from that were experts on this period. And we had several papers. We even had one in Scientific American not long ago about this mutation that increased. It's called the fat gene because when you got this mutation, you could become much more sensitive to sugar. So it had that advantage that at the time it helped us survive because basically our ancestors were starving to death, and then but with this mutation we were able to make it through. And but then now we're susceptible to gout because we have higher uric acids, and we're more susceptible to more sensitive to the effects of sugar. So when we eat a lot of sugar, we get a bigger response. So if you take a mouse and you give it a lot of sugar, it will get fat, but you have to give it a ton of sugar. But if you give the same kind of a relative amount for the weight of the mouse, if you give that to a human, you're going to see major effects. We are more sensitive to sugar than most animals. We like sugar. I like sugar. I don't know. Do you like sugar, Richard?
Yeah. I'm drinking a coffee as I talk to you, and it has some sugar in it.
Oh, there you go.
So what do you tell people with all your knowledge? What do you tell people clinically then? What's the message from you that's different or more effective for people? I know everyone's different.
Well, we've done a lot of work, but one thing I can tell you is we've kind of we figured out that part of the way sugar works is to stimulate a hormone that makes you want to hold on to water. And it turns out that hormone, which is called vasopressin, also tries to drive fat production. And the reason is when you make fat, you actually are not just storing energy, but you're sort of like storing water, because when you burn fat, you produce water. And so it turns out that, like whales, for example, they get real fat because they don't drink salt water. And when they break down the fat, they make fresh water from the fat, and they also get fresh water from the food they eat. And animals in the desert also use fat to produce water when there's not much water around. So it turns out that sugar drives up this hormone that makes you want to hold onto water, and it's partly because people who are overweight tend to be dehydrated. And we did some studies where we gave water and found that if you drank a lot of water, you could suppress a lot of these pathways. And so the basic message that's kind of a nice one is the old wives' tale that if you drink 8 glasses of water a day, it helps you not get fat is actually true. And so if you want to take some pounds off, try to cut back on sugar. Try to drink about 6 to 10 glasses of water a day, and that'll help you. So that's my little ending message, I guess. So yeah, you've got some water in that coffee cup. Just got to take the sugar out.
Yeah. What's any big levers on what people can do to help themselves? Do you run into patients, for instance, that just seem to be incredibly resistant to losing weight? And if so, any insights into those kind of people's circumstance?
The first thing is you got to find out what your kryptonite is. So what you got to do is you got to have them talk to you about what they like to eat and what's their favorite food and what do they tend to. Are they a nibbler? What are they eating between meals? What is their kryptonite? Because they're probably getting something that's either got sugar in it or it gets turned into sugar in the body. So that's the first step. And then you kind of, you do all the usual stuff, tell them to, try to avoid liquid sugar, try to drink more water. But, one of the things is to try to find out if they have a particular food that they're eating and try to help them get off that and try to figure out how to block craving. There are different things you can do, but like taking the natural fruit, artificial sugars. None of us like artificial sugars, but they do, for the most part, they can help a person in the acute phase from trying to get off sugar. And then intermittent fasting does work. There's lots of different techniques, actually.
Okay. I know that there's been a debate on, let's say, diet sodas or, fake sugar or, non-natural sugars. Do you have any insights on that? Do you think that they're harmful or not harmful, and why?
Yeah, sure. So we've actually done a lot of studies with diet sugars, and for the most part, the first rule is that sugar is a lot more powerful at driving fat and so forth, and diet sugars don't do that in the animal. There's one exception. Saccharin does have a little bit of effect to cause a little insulin resistance through its effects on the gut. But for the most part, artificial sugars do not cause obesity. They do not cause diabetes. Here's a good example. If you knock out the sweet receptor so that an animal can't taste sweet, you give it sugar, it will still love sugar, even though it can't taste it, and it will still get fat. But artificial sugars, they don't care for artificial sugars once you knock out the sweet receptor. But even if you give a lot of artificial sugar to an animal, they won't get fat. So the artificial sugars are not causing obesity. There are a couple exceptions. There's this, like the low sugar ice creams and stuff that have sorbitol, low sugar syrups. Sorbitol, maltitol, these sweeteners can be converted to fructose in the body, a little bit of them. So it's sort of like eating 1/2 the strength of fructose. So it's a little better than eating sugar, but you're still getting sugar. But most of these things like Splenda, stevia, you're not getting the obesity or diabetes type of effect. Having said that, a lot of these artificial sugars have substances that we don't necessarily think are necessarily good for you. So Splenda is a chlorinated carbon. We don't really. It's been fairly safe in most testing, but everyone's a little bit worried about it. Aspartame, some tiny bit of it gets converted to formaldehyde. That doesn't sound good. So none of us are really excited about artificial sugars. We like to eat natural things, but they're definitely safer than regular sugar when it comes to risk for obesity and diabetes. And if you're trying to get off sugar and you really desire something sweet and you can't, you can't eat a fruit, well, then maybe a Diet Coke is okay as you try to wean off sugar.
Okay. Yeah, I got you. Any drugs that are out there or ways to block production of fructose in the body, at least partially?
Yeah, there's I have to confess that, I have a little startup company and we're trying to make inhibitors for fructose and we're moving along, but other groups are moving along as well. And probably the company that has the most exciting preliminary work is Pfizer. And they have a drug that's, they're going to phase 3 now, or phase 2B maybe, with their fructose inhibitor. And in preliminary data, preliminary studies in phase 1 and 2, they got some pretty good results suggesting that it may really be beneficial for preventing diabetes and fatty liver and all that kind of stuff. So they're coming.
Okay, well, that's great.
Yeah.
Well, Rich, what's the best way for people to get in touch? Maybe to read through the hundreds of papers you've written, or at least start on this. Start with getting some information.
Well, Richard, if they want to go to PubMed, I've written a number of papers that are kind of just general knowledge papers for people who want to know about sugar. But I also have 2 books. I have a book called The Fat Switch that really gives a nice overview of this whole thing. And that book is available through the Mercola website, but also through Amazon Kindle. And I have The Sugar Fix, which is a little bit older book, but it was the first book with a low fructose diet from Rodale, 2008, I guess. And you can Google. I'm on YouTube a little bit. So I was just on the Peter Attia's podcast.
Oh, really? Yeah, Peter's got a great podcast. It's cool.
Yeah, so just on that. I'm in a National Geographic August 2013 issue cover story by Rich Cohen and Scientific American. I can't remember when that came out, but yeah, just
okay. Yeah,
Richard J. Johnson. That's all right. That's my sales pitch.
No, that's great. Rich, thanks for coming. It's been a really good call. I appreciate it.
Yeah, great, Richard. It's nice talking to you, and I hope you get that sugar out of the coffee, will you?
Working on it. Thank you.
Okay, take care.
All right.
Forget frequently asked questions, common sense, common knowledge, or Google. How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5% go above and beyond and become very good at what they do. But only 0.1% are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in fields such as sleep science, cancer, stem cells, ketogenic diets, and more. Get ready. Here come the geniuses. This is the Finding Genius Podcast with Richard Jacobs.